Hi guys, the next unit we're going to do is order of operation, or what we will discover is GEDMAS. And of course, you guys are probably thinking, well, I've heard of BEDMAS before, and it's about the same thing, but I like to use GEDMAS because the G stands for grouping instead of brackets, parentheses, blah, 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 blah. Anyway, we'll come back to that. The key is, for this video, is I need you guys to be okay with this part, E. And what that stands for is exponent. So at this point, we're just going to do some very basic exponent stuff. We're not going to go into much about simplifying exponents or anything like that. We just need some basic understanding of exponents in order to do our order operations unit. And then we'll come back to the higher level exponent rules and things later on in the course. So when we're talking about exponents, we're talking about something like this or something like this. Okay, so 2 to the 3 or x to the 3. So we'd say that's 2 cubed or x cubed. You could also say 2 to the 2 or x to the 2, and that would be x squared or 2 squared. So when we look at these, this part here is the base. So the number that is to an exponent is called the base. The exponent itself are these little numbers that we put up there. Okay, so you have a base, which is the number, and then an exponent. So for example, if I wanted to write a base of 4 to the power of, or to the exponent of 5, it would be 4, and my exponent would be 5. That is 4 to the power of 5, or 4 to the 5th, or 4, 5, whatever you want to call it. Okay, it's 4 to the exponent of 5. What that means is not 4 times 5, but it means 4 times 4 times 4 times 4 times 4. So it's 4 times itself 5 times. So whatever that happens to be, I don't have my calculator handy, but you guys can do that math, no problem. That's 4 to the 5th. So let's take another look. If I have 2 to the 3, or I have x to the 3, or I have 1/3 to the 3, what that is itself times itself 3 times. So this is equal to 2 times 2 times 2. This is equal to x times x times x. You'll notice that I went with little dot. In algebra, we're going to use that little dot, or we can also use brackets to show that. Those things are multiplied, but we'll talk more about that later when we get more into variables. We just don't use the time symbol because x times x gets really confusing when you have a multiplication symbol in there. And then we have this guy here, so this would just be 1/3 times 1/3 times 1/3. Okay, so no big deal there. So we'd evaluate this. 2 times 2 is 4 times 2 is 8. X times x times x is still x to the 3rd. Okay, we don't know what x is, so it's still x to the 3rd. There's no really point in evaluating those. And then 3 times 3 is 9, times 3 is 27, so this is 1/27. Okay, so those ones are pretty straightforward. You have a base to an exponent, so you take the base and you multiply it by itself that many times. Sometimes we have to deal with negative numbers. So you guys will look at integers in your self-study, and you'll realize that there are obviously negative numbers that we have to deal with sometimes. So for example, I just want to quickly point out a little bit of a difference here between -2 to the 3 versus -2 to the 3. Okay? The first one is -2 times 2 times 2. That would give us a -8, okay? Because 2 times 2 times 2 is 8, and then we have the negative outside. But if I'm doing -2 times -2 times -2, then I have -2 times -2 times -2, which will also give me a -8. So you notice that when the exponent is 3, and this will also work when the exponent is 5 or when the exponent is 7, anytime you have an odd exponent, it doesn't really make a difference. When it will make a difference is here, -2 to the 4th and -2 to the 4th. Those will come out differently because of the way integers work. So this is -2 times 2 times 2 times 2. This is negative 2 times negative 2 times negative 2 times negative 2. This top one will end up being negative 16 because you do all the 2 times 2 times 2 times 2 business, then you put a negative out in front. This one, negative 2 times negative 2 times negative 2 times negative 2, all those negatives kind of go away and become 16. And in your self-study, you'll figure out why they go away, because a negative times a negative gives us a positive, okay? So this will be negative times a negative will give us a positive 4. Negative times negative gives us a positive 4. Multiply those two things together, and you get a positive 16. So with even exponents, it's really going to matter if that negative is in the brackets or not, okay? One other special rule that we'll learn at this point is anything to the power of 0. 4 to the 0, x to the 0. Whatever number this happens to be to the 0. Anything to the 0 is 1. If you don't believe me, you can put it in your calculator and put the biggest number or the smallest number you can imagine and put it to the 0, and you will end up with a 1. Another type of rule to understand is that anything to the 1 is itself. So 4 to the 1, x to the 1, whatever that number was, to the 1, that's just equal to itself. Okay? So to the 0, it is equal to 1. To 1, it is equal to itself. The base to the power, and the power is the exponent. You're going to multiply that base by itself the amount of times that the exponent says to. So that should be enough at this point to get you through the exponent section of GEDmath, which we're going to learn. One other quick tip, and think about this. If you have something like negative x plus 1, no, let's just do this here. If I have negative x plus 1, and I have x plus 1, and it asks you to, well, we'll make it squared just for fun, and it asks you to evaluate if x is equal to a negative 3, say. Okay? So evaluate, can't spell. Evaluate if x equals negative 3. So what you're going to do is you're going to put in negative 3 for x, but you've got to be careful because this is when that bracket thing is going to be important. So what you're going to do is, I'm going to erase this, and I'm going to put in that negative 3. Now careful what happens here. This is a negative 3, then this one is a negative 3 squared. Okay? So I put in a negative 3 for x, so I have to put it in brackets, and then I'm going to square it and add 1 to it. So you'll notice that when I put it in this top one, I still keep that negative outside, so I'm still going to end up with a negative answer. For instance, this one, negative 3 squared is a positive 9, but I have a negative outside, so I end up with a positive 9, negative outside, plus 1, and you will learn in your integers unit that that is equal to negative 8. Here, however, I have negative 3 squared plus 1, so that is going to be 9 plus 1, 10. So very different answers. You have to be very careful with if what you're plugging in is negative, and being careful of putting it in brackets when you do so. Until you get very used to this, you're going to want to put it in brackets to stay safe. Anyway, that's enough about exponents for now, and that will get you through our lesson on the order of operations until we come back to exponents in the exponent unit.